Greetings, metalheads and friends from the future. If you're watching on a video sometime later, welcome to Metal Monday. Aware that it's not Monday, even if you're watching live. Time zones are very hard, and computers even harder. But I will be here with you today, and joined by friends Jason DeTiberus and David McKay.
Hey.
Welcome. So today we're going to take a look at the cluster API for getting Kubernetes up on bare metal. I suppose Jason has the most familiarity with cluster API, and so if you can give us a brief run of what the project is, where it came from, what we're going to do with it.
Sure thing. So the whole idea behind Cluster API is declarative management of infrastructure for Kubernetes clusters. We sat there and wanted to solve the problem that pretty much everybody was trying to solve after Kubernetes came out, was like, how do you get a Kubernetes cluster in a repeatable way? So when we started building it, there had already been quite a few different installers out there and different lifecycle management tooling for Kubernetes clusters. But each of them had their own kind of quirks, either relying on very specific tooling like Ansible or Terraform to do what they needed to do. And we wanted to make sure that we had an approach that was more kind of agnostic, that would try to meet users where they are more, allow them to use the tooling that they're already using to kind of manage these clusters in a declarative way. And we thought, there's a system for managing declarative state with Kubernetes. So basically, can we find a way to use Kubernetes to manage Kubernetes? And that's kind of what brought about the Cluster API. And today it's built on custom resource definitions in Kubernetes. And you do need an existing Kubernetes cluster of some kind to get started. But you can even start with a local Kubernetes cluster and then move things around to a longer term cluster. So it's not like, we have ways to work around the chicken and egg scenario of needing Kubernetes to get Kubernetes.
Yeah, I was going to ask about it being that sort of delicious distributed system sourdough, where does your the main ingredient in sourdough is the sourdough, and so where does it come from? But yeah, if you're saying that I'm going to be able to bootstrap using a I think in the case that we'll illustrate today, Docker for Mac or any existing Kubernetes, getting the first one is from the Kubernetes and Docker, just as push the button, get some Kubernetes.
Yep. And in general, what we've seen in the wild is that users don't generally just run one Kubernetes cluster. They generally have multiple Kubernetes clusters, whether it's having clusters for different types of security and application requirements, or even just giving development teams their own Kubernetes cluster and having a production cluster out there. There's very few people that are managing just 1 or 3 Kubernetes clusters. And that's kind of where Cluster API really shines, is when you need to manage multiple Kubernetes clusters.
Yeah, I think we can probably start a demo, and as we walk through, talk about how it's working. Let me give my screen a share here. Perfect. And so I've already dropped an Equinix Metal API key in here. And so, which is Equinix Metal being the artist formerly known as Packet. I believe the provider is still known as Packet for a short time.
It is. We haven't yet had the chance to sit there and create the new repository for naming and doing all of that within the greater Kubernetes community, where there's a little bit more process involved than some of the self-hosted repositories that we have.
All right, looks like that. Looks like we got our provider all right, and the management cluster is inside, up inside here. Our Docker for Mac, and then the workload cluster we're going to need to make, and that'll be on bare metal, Equinix Metal. I've already input my Equinix Metal API key. Otherwise, that would be a something that would go in there. So we'll put all these bits into our environment. So. Have an SSH key. For facilities, we can look at the list of facilities that we have available here. Available from our API, just api.equinix.com/metal v1 facilities. And currently there are these 6 places where machines can go. I'm going to drop one into Virginia, which is DC13. I've cleaned up the JSON that's returned by the API a bit, but it gives you all of these bits back. But for a cleaner view, there's our 6. All right. So for facility, we use DC13. The types of machines that are available to me, we'll grab one of these, that C3 small. And set that as what we'll be using for our control plane. Use the same machine type for our worker nodes.
Yeah, and obviously anybody wanting to run these would want to tweak these to their specific requirements. But that C3 small type is still a rather beefy machine compared to most cloud providers.
And then we're going to be working from the more or less this quick start here from the cluster API book, and so we'll link this in the show notes down here, but which is why you'll see the name cluster API quick start a bunch of places. You'll be able to follow along or get ahead of us if you're watching in the future. And cluster cuddle config, cluster API quick start. We'll be using version 1.18.2, 3 control planes, 3 worker machines, and storing that in cluster API quick start YAML.
And it looks like you're running with a slightly older version of cluster cuddle, but that shouldn't cause us any issues today.
And just giving a quick look to the YAML that was generated.
We may not want to give too quick of a look to it, or too much of a look to it, because of the way that we're bootstrapping machines today, because we don't have images. We don't have a way for generating images for use with Cluster API yet within the Equinix Metal. So we're working around it a little bit by basically downloading the bits that we need and installing them at runtime instead of from a pre-baked image.
Okay. kubectl create with that YAML.
And so at this point, we can run kubectl get cluster API, and it should return all of the resources that we just created. You want a dash in there, I think. And I think I saw that first control plane instance pop up on the web console in the back there.
Back here. Yep. Looks like it is coming up. Magic install system. And so for the to adding CNI, the next step is, I believe, if I've read ahead, Docker, Mac OS, I've initialized provider, creating first workload cluster. Yep, there's the environment information that we added in. It's a quick start. We're at apply right here, the output.
Yep, and now what we're basically waiting for is that control plane resource that we just created to become initialized. And that'll tell us that that first control plane instance bootstrapped through kubeadm and init, and we can actually talk to the API server at that point. And this process takes a little bit, mainly because we are bootstrapping bare metal here. We do have to install an operating system image on the hardware. And then after that comes up, we're installing all of the prerequisites. So we install containerd, we install all of the Kubernetes binaries, and then we run the kubeadm init command on there. So that process takes a little bit, but it shouldn't take too long here. The other thing to note, when we first bring up the initial cluster resources, there's also a packet cluster resource within that list of resources. And one of the things that does is it searches for a pre-existing elastic IP that we can use for the control plane, or it creates one. And that gives us the ability to have kind of a persistent control plane endpoint. And that's required for various reasons, because Cluster API treats all of the underlying machines ephemerally. The way that we do upgrades and scaling operations and things like that, we don't expect that the existing machines that are behind everything are still there after we finish those processes. So upgrades create new instances and then delete the old instances. So because of that, that elastic IP gives us the ability to have a single control plane endpoint that's persistent throughout the life of this cluster. And now we can see that it is initialized. So we should be able to go ahead and grab that kube config and go ahead and apply a CNI provider, which will allow the cluster to finish provisioning, because until you have some type of CNI solution, Kubernetes doesn't really become functional up until that point.
All right.
I think one of the important things to note too is that in the quick start and here we're using Calico as the CNI solution. You aren't limited to just using Calico with Cluster API. You can use pretty much any CNI solution that you want. But if you do use another CNI, you might have to tweak the cluster templates in various ways to ensure that things like the pod CIDR address that's used, or if the CNI requires any particular changes to some of the flags for the different control plane components, that you set those appropriately with the cluster template for the CNI provider that you're using.
And then, yeah, back in our dashboard, you can see the 3 workers coming up. 2 of them look like are already ready, and 1 ready real quick. Step 11.
And one of the other things that we should see is with that kube config that you pull down, we can run kubectl get nodes on it. And we should be able to see how many of those instances are actually bootstrapped and ready.
Using the cluster API quick start config.
Yes. Yeah.
Yeah.
Yep, and we can see right now those 2 workers that we saw come up haven't quite gotten through the finished the bootstrapping process yet, but we do see the initial control plane instance that we had created, and that it's now in a ready state. And because now that it's in a ready state, here shortly, the kubeadm control plane should go ahead and create the next control plane instance. And because the way that we're managing the control plane with the default kubeadm control plane provider, the actual control plane components, the API server, the scheduler, and the controller manager are all running on the same instances as the etcd server. So we take things as conservatively as we can, and we only create 1 instance at a time to avoid any potential issues with losing quorum and things like that with the etcd cluster.
Got those first 2.
Yep. And if we do another look with kubectl get cluster API against the management cluster, we should see what's going on there. All right, yep, and it looks like we are going ahead and creating the second control plane instance now as well. And like I said, we do things relatively conservatively, so we're going to wait until that control plane instance is fully up, has done all the bootstrapping steps, has joined the cluster, deployed all the control plane components as part of the kubeadm join process, and then wait till everything is ready, etcd is healthy, and then only then do we move on and we'll create the 3rd instance. One of the fun things we might notice here too is that in the case of going from 1 replica to 2 replicas, you'll actually have a short period of time where the API server will lose access to etcd, because when you're scaling the etcd up to 2, what you actually do is you actually lose quorum for a short period of time until that second replica actually syncs the data and becomes a voting member, and then they can reestablish quorum at that point.
And so then more or less ready to go at that point then, yeah?
Yeah. I think one of the other good things we can probably note as well is that when you ran the cluster cuddle config command, that populated the templates with the values that existed both in the defaults for the templates and also with the environment variables that you set. And you actually just wrote that file out to disk. If you are using some type of GitOps style management, you can incorporate those templates into there. Or there are even some other interesting approaches, such as the Pulumi work that David has put together for actually managing cluster API resources natively with Pulumi as well.
You said the magic word. David, tell us about Pulumi.
No. Yeah, it's something I've been working on for a little while now, and I've broken it twice to the point where I'm at the third time of writing it. I think this is now the fluid. I mean, for me, writing a handcrafted YAML is not something that I personally enjoy doing, and I know that there are loads of really smart people going in the Helm route of providing the Helm charts to provide cluster API YAMLs and stuff like that. But I wanted to try and do something a little bit more novel. For anyone who's not familiar, Pulumi is a tool that allows you to use whatever programming language you like, provided there's a supported SDK, to define your infrastructure. A kind of a combination between like what Terraform is doing and CDK and those other tools. So why I like the Pulumi approach is that they have a tool for generating types and TypeScript based on Kubernetes CRDs using their open API specification. Using that, I was able to generate TypeScript types for the cluster API and the Equinix Metal Provider CRDs, and then I started just layering on abstractions on top of that, to the point now where you can type cluster CTL in it as a function call in Pulumi, and it will use their management, it would target your management cluster and install all the components and provision the provider for you. From that, you can then do create cluster, give it a name and a version, and it generates all of the resources. You don't really need to understand what a machine is, or machine deployment, or machine set, or any of these other components. It's just like a really simple interface to creating clusters. And of course, if you want, you can then say, well, actually, I want multiple node pools, and I want them to run different operating systems, and you can kind of connect the dots and break it down that way. It's very much a work in progress. I have a talk at FOSDEM and 1 month today, the 6th of February. So I'll be, cleaning up and adding documentation to these repos, and I'll be talking about it a lot more publicly soon. But for now, it's very much a work in progress, and hopefully going to get better soon.
And I think that broaches on a quite important topic that I haven't mentioned yet, and that's that Cluster API really isn't trying to be the easy button approach towards creating Kubernetes clusters. What we're trying to do is build upon what kubeadm has already done and kind of generalize what a lot of folks are already doing, and trying to create that kind of base platform to allow folks to build, whether it's a Kubernetes installer or other types of Kubernetes lifecycle management tooling with Cluster API. So in a lot of ways, we stay very unopinionated because of that. And it does tend to be overly verbose, but we do expect that, like the work that David's doing with Pulumi and other tooling will come in to provide kind of that nicer user interface that we would expect users to actually interact with, where Cluster API would be kind of the more low-level implementation details.
Excellent. And so, sorry, things that would be good to do next would be probably move the management cluster away from my local, and then either to it can either be moved to itself or to any other Kubernetes cluster?
Yeah. So basically, the way we look at it is you definitely don't want to be using like a local Kubernetes cluster for managing these Kubernetes clusters. So unless you're just trying to spin up an instance and not manage it over time, which eventually you're going to want to upgrade the Kubernetes cluster and things like that. So you generally want to either move it to the cluster that you just created, and there are some folks in the community that just use kind of self-managed clusters with Cluster API. Or if you wanted to have a single management cluster to run multiple clusters, that's okay as well. Just please don't do it, in Docker for Mac or Kind long-term. So the way that we can accomplish that is we already have our workload cluster here. We could basically rerun clusterctl init again and point it towards the cluster that we just created and turn that into a Kubernetes management cluster. And then there's another command with clusterctl move, that will actually do a safe moving of the resources from one Cluster API management cluster to another. And one of the reasons why I say safe is there's a lot of ways that if you tried to do this without using clusterctl move, that you can inadvertently cause some problems. One of the things you want to avoid is you don't want to have two controllers kind of reconciling the same set of resources, because then you end up with kind of these two clusters fighting each other over the management of those resources. The other issue that you have is you also don't want to get into a situation when you go to delete the local resources from your Docker for Mac cluster, that you actually delete the underlying instances for the cluster as well. So if you just did like a clusterctl delete of the machines locally, and more particular the packet machines and the packet cluster, it would actually delete those resources for the actual cluster itself. So clusterctl move actually makes sure that it performs the move operation safely. It kind of pauses reconciliation of all the resources while it creates the resources in the new cluster. And then it kind of does what we kind of call like a force delete on them, and it removes the finalizer so that if it wasn't paused, it wouldn't accidentally reconcile the actual deletion and things like that.
If folks are looking to help out, where's the best place to start when contributing to the project?
So I think the best place to start, it depends on how you want to help out. Obviously, we have the documentation out there. So any help there is more than welcome. We also do have quite a few issues that are marked as either help wanted or good first issue. We try to keep that list curated so that folks that are looking for things to do can kind of go to the issues and just search for those tags and pick something up. In general, we try to assign issues to folks, and we have a lifecycle active tag that we generally apply to issues when they're actively being worked on. So even if something's assigned to somebody, if you don't see that lifecycle active tag, then chances are nobody's actually working on it. And if you're interested in it, generally just reach out to the person who's assigned to it, or reach out to any of the maintainers, and just to make sure that you're not duplicating effort. But generally, if the active tag's not on there, it's free game. The other thing is we have a Slack channel in the Kubernetes Slack cluster API, and we have a weekly meeting for the core cluster API project on Wednesdays at 1 p.m. Eastern, US, or some of the different providers have different office hours at various points in time too. So if you're more interested in the providers, a lot of the providers have their own Slack channel in Kubernetes Slack as well. Or feel free to reach out to me or anybody else in the Cluster API channel, and we can point you at the right places to go for sure.
Excellent. I will link every one of those in the show notes as it so that it's easily clickable and findable in the future. Yeah, approaching a probably a good break point and a good end of time. Anything else that you'd be interested in adding, or send folks out?
So I think one of the interesting things is, and we don't necessarily have to run through it, but I did want to mention that we did mention like upgrades and things like that. If you are looking at how do you upgrade your cluster, so when you stamped out this cluster, I think it was a 118.1 cluster. Obviously, we have new releases both in the 118 release and also in 119 is out there now. Or 1.20. You could choose, basically all you have to do is upgrade the kubeadm control plane resource, rev that version if you're not doing anything custom with the kubeadm configuration, and then wait for the control plane to finish upgrading. It'll do it one instance at a time. Once that's upgraded, you'd go to your machine deployment and do the same thing, rev the version there, and it'll roll through the individual worker machines and upgrade those as well.
Are there any rules that have to be followed? Like, Jeremy's on a 118.2 right now, it looks like there. Should he be upgrading to a 119 first? Is he safe to go straight to 120? And does the reconciliation loop provide any helpers there?
Yep. So there are some gotchas there, obviously, and that's mostly limited by the core Kubernetes project. You can upgrade the patch release for a particular version. You can upgrade to the any patch release version in the next minor release. So from here, we could go to any 1.19 release, but you don't want to skip any minor releases with the Kubernetes upgrade. That's just something that the project doesn't support at this point. And truthfully, I don't know if we have safeguards or not. We can check and see.
Let's do it.
And I'm assuming, the original control plane nodes are going to be there, happy and healthy. If anything went wrong with the new node coming up, the reconciliation loop nothing would break in the interim. Is what I kind of get to there, right?
Yeah. As I said before, we're relatively conservative with the control plane, so we would try to create the new instance. If anything failed with that new instance coming up, all of the existing instances would be there. You would have to do a little bit of manual work to do like a full rollback at that point. You'd have to basically delete the instance there. You'd have to go in and change the version back and things like that. But it is possible to do a rollback from an upgrade, assuming that the upgrade hasn't fully completed. Because the issue that you're going to run into there is there's all these sorts of weird edge cases around downgrading, especially related to the stored resources within etcd and things like that. And for that reason, we don't natively support downgrading clusters with Cluster API.
Yeah, I think this is one of my favorite things about the Cluster API is like all these safeguards are in place, and the reconciliation loop takes the knowledge and experience from people like yourself. And nobody has to know all of these concerns. Like Cluster API is going to do the best thing for me. I think that's great.
Yeah.
All right, what's my fastest path to an upgrade here?
So the first thing you'll want to do is kubectl edit the kubeadm control plane. Oh, yes, kubectl, not kubeadm. Apologies there. And you can actually abbreviate it KCP if you wanted to, just to avoid typing. And then down in the spec, will be a version field. There we go.
We're going 119.
Sure.
You'll need the patch version on that.
Yeah.
So it'll need to be v119 .4. I can't remember. Was there a .5? .4.
We got a .6 looks like the latest.
There we go. Yeah. Yeah, easy.
Yep. And again, it'll take a little bit because it's going to spin up just one instance at a time. It's going to make sure that it's healthy, and then it's going to delete one of the old instances and just keep going with that.
Oh, there's the new one.
So if you run get cluster API again, we've already seen that the kubedm control plane is updated, and we should see some new things happening here. Yeah, right there in the middle. There we go.
Yep.
Yep.
And we can also see that the kubedm control plane is showing that there are now actually 4 replicas, 3 of which are ready. Only one has the updated configuration, and that happens to be the one that's unavailable right now.
So once this one comes online, does the cluster API, does it spin up another control plane node? Will we have 6 control plane nodes, or does it take one down and then work on the next one?
It will only surge one at a time. And basically, the idea is that we don't want to surge too much because that will change the kind of failure capacity of the etcd cluster. So if you go from 3 etcd nodes to 4 etcd nodes, you have the same, you actually get in the spot where you can only lose one of the original ones and you still retain quorum. If you surge to a 5th one or a 6th one, you're kind of changing that quorum profile quite a bit. And if you're trying to distribute things across various different, in our case, it would be different racks within a facility. It would be a lot more difficult to kind of maintain that balance, by surging too much before we actually scale down the original ones.
That's good to know.
And we are actually working upstream. There's some folks working to try to add the ability to scale in during upgrades. So if you were looking at having, say, reserved instances and using those reserved instances for your Kubernetes cluster, today, if you wanted to actually upgrade that cluster, you would either have to play around with things like scaling down a machine deployment to make slack for upgrading your control plane, or you would have to have an additional hardware reservation in place to allow that slack for the upgrade to happen. In the future, you'll be able to actually do a scale in type of upgrade and just have the exact amount of reserved hardware that you need for your Kubernetes cluster. However, we don't really recommend that approach for upgrading just because it does take away some of the safety that we build into the kubeadm control plane. By scaling down, now you're reducing that failure profile for your cluster. And if you have any type of failure that happens during the upgrade process, it can actually cause your cluster to lose quorum, and you don't necessarily want that unless you decide that is an acceptable risk that you're willing to take.
But yeah, that one is up and ready, yeah?
Looks like it. Let's run that get command one more time and see. Because I think we're probably in that state right now to where the instance has finished coming up in the API, but it's still performing those bootstrap steps. So it's not quite ready as far as the control plane is concerned.
Yeah, we could run kube control get nodes on the target cluster, right? And probably get a slightly easier to node list.
Yeah, for sure. Yep, and we can see we got that fourth control plane instance there, and it's not quite ready yet, which means it's probably still deploying the CNI pods. And
interest in the version is reporting as 1.18.2. Is that just because it's not checked in yet, or?
That is odd. That is not quite what I would expect.
Quick clear screen, Jeremy. We never saw anything. Do you want to run that again and see if it's ready at least to see?
You know what I think is happening? It's because of the way that we're bootstrapping the machines. We have that embedded in the kubeadm config potentially.
Oh, there will be one more issue.
Yeah. So I think we need to double check on that to make sure that the version's coming from the right place there.
Okay. So something went a little bit strange there, but we'll get it fixed. No worries.
Yep.
Sure enough. All right. Yeah. 1 minute to the 1 minute to the top of the hour. Are there anything further or good sign-off time? Sounds a lot like good sign-off time. All right. Those who have stuck with us, thanks so much, friends from the future. Hope that was hope you enjoyed that. There will be plenty in the show notes, and we will see you next Monday, probably on Monday. Until later, so long, metalheads.